Welcome to this lecture titled Categories and Levels of Artificial Intelligence. In this lecture, we will look at how artificial intelligence can be grouped in different ways. We will distinguish between narrow, general, and super intelligent systems, and we will also discuss the difference between weak and strong artificial intelligence. Artificial narrow intelligence refers to systems that are specialized for one task or one limited domain. For example, a system may be very good at recommending products, recognizing faces, translating text, or playing a specific game. The important point is that this ability does not automatically transfer to other tasks. A system that performs well in one area does not therefore understand the world in a general way. Most artificial intelligence systems used today belong to this category. They can be highly useful, but their intelligence is narrow and task-specific. Artificial general intelligence refers to a system that could learn, reason, and solve problems across many different domains. The key idea is flexibility. Such a system would not only perform one task well, but would also be able to handle new and unfamiliar situations. This is different from today's narrow systems, which usually need a clearly defined task and a specific context. Artificial general intelligence would instead be closer to human cognitive ability, because it could transfer knowledge from one area to another. At present, artificial general intelligence remains a long-term goal rather than an established technology. Artificial superintelligence refers to a possible future form of artificial intelligence that would surpass human intelligence in many or nearly all domains. This could include scientific reasoning, creativity, strategic planning, social understanding, and problem solving. It is important to present this carefully. Artificial superintelligence is not something we currently have. It is a theoretical concept used in discussions about the possible future development and risks of artificial intelligence. It is often connected to the idea of self-improving systems, where an artificial intelligence system could improve its own abilities and thereby accelerate further development. Artificial intelligence tasks can be understood as a spectrum. At one end, we find systems that perform relatively limited tasks, such as searching, sorting, classifying, or recognizing patterns. Further along the spectrum, we find systems that can reason, plan, adapt, and work with more complex situations. This does not mean that all systems are moving smoothly toward human-level intelligence. Rather, the spectrum helps us describe different kinds of capabilities and understand why some artificial intelligence systems are narrow, while others are imagined as more general. Another common distinction is between weak and strong artificial intelligence. Weak artificial intelligence refers to systems that can perform tasks that appear intelligent, but without general human-like understanding. Most artificial intelligence systems today fall into this category. They may be powerful and useful, but they are still limited to specific tasks and contexts. Strong artificial intelligence, in contrast, would involve flexible human-like intelligence. Such a system would be able to understand, learn, reason, and act across many different situations. This remains an ambition rather than a current reality. It is common to connect artificial narrow intelligence with weak artificial intelligence, and artificial general intelligence with strong artificial intelligence. This connection is useful, but it is not a perfect mapping. The categories of narrow, general, and superintelligent artificial intelligence describe the level or scope of intelligence. In contrast, weak and strong artificial intelligence describe whether the system merely performs intelligent tasks or whether it would have more general human-like understanding. So, these terms overlap, but they do not describe exactly the same thing. The categories we have discussed help us understand what counts as artificial intelligence and what does not. Artificial intelligence refers to systems that perform tasks such as learning, reasoning, classification, prediction, planning, or pattern recognition. However, not every advanced digital technology is artificial intelligence. Some advanced technologies can support artificial intelligence systems or be combined with them, but that does not make the technology artificial intelligence by itself. For example, blockchain is an advanced technology, and some blockchain systems use cryptography, distributed databases, and game theory. But blockchain is not artificial intelligence by itself. This distinction matters because clear definitions help us avoid treating all new digital technologies as if they were the same thing. Let us briefly compare the categories. Artificial narrow intelligence is task-specific. It can perform one task or a limited set of tasks very well, but it does not have broad understanding. Artificial general intelligence would be more flexible. It would be able to learn, reason, and solve problems across many different domains. Artificial superintelligence goes one step further as a theoretical idea. It refers to artificial intelligence that would surpass human intelligence in many or nearly all areas. Weak and strong artificial intelligence describe a related but different distinction. Weak artificial intelligence performs intelligent tasks, while strong artificial intelligence would involve broader human-like understanding. To summarize, most artificial intelligence systems used in practice are still task-bounded or application-specific. They can be powerful and useful, but they are usually designed, deployed, and evaluated within particular tasks, products, or contexts. At the same time, the strongest frontier models are no longer easy to describe as only narrow systems. Many of them are better understood as general-purpose artificial intelligence models, because they can support many different kinds of tasks, such as writing, coding, reasoning, image understanding, and planning. However, this does not mean that artificial general intelligence has been achieved. Artificial general intelligence remains a research goal and a contested concept. There is still debate about how it should be defined, measured, and evaluated. Artificial superintelligence is even more speculative. It is mainly used when discussing possible future developments, risks, and long-term scenarios. The main point is that clear definitions matter. They help us avoid confusion between narrow systems, general-purpose models, artificial general intelligence, and theoretical future forms of artificial intelligence.